Okay, the most polar bond, remember we were trying to do? I went home and checked the electronegativities, right? So what I said was correct. The carbon fluorine was the most, because when I subtract the electronegativity of the most electronegative atom, and from then they subtracted the electronegativity with the least electronegative atom, then I got a difference, right? For carbon fluorine bond, it was the highest, right? Therefore, it's the most polar bond, right? So we done that. This next question, okay. Now let me introduce to this one a little bit more. Why we are doing this? Let me get some slides also here. Chapter 12 slides. Now basically organic compounds are hydrocarbons and hydrocarbon derivatives. Hydrocarbon is carbon and hydrogen only, right? And the derivatives are when the hydrogen is, one of the hydrogen is replaced by another group, like functional group, what we call it OH group, OH alcohol functional group, or carboxylic functional group, or other various functional groups. That's what I'm going to do next. Now, also if you look at hydrocarbon side, we're going to, in the same homework, we're going to look at two different types of hydrocarbons. The difference is hydrocarbons contain only carbon and hydrogen, and the saturated hydrocarbons, same thing, that contain carbon and hydrogen, and also they contain single carbon-carbon bonds. Carbon-hydrogen bond always going to be single. But when you look at the unsaturated hydrocarbon, you're going to see, right, unsaturated has at least one double bond or triple bond. It could be more than one double bond or triple bond. So no longer all bonds are single, right? So they're called unsaturated. You understood this now, right? What we're going to do here is basically first look at the derivatives of different derivatives of hydrocarbons here. They are organic compounds coming from substituting a hydrogen on a hydrocarbon chain. Okay, so first one is called CH2. This is the condensed formula for hydrocarbon. 4 hydrocarbons, that's the hydrocarbon, right? 4 carbon atoms. If you take out one hydrogen, that's a vacant bond there, then you put a OH group, then it becomes an alcohol. These are the functional group is an alcohol group. Okay, functional group is an alcohol. There are various groups, the various alcohols where the this part is different, but it's still the OH is there. Propyl alcohol, ethyl alcohol, propyl alcohol, butyl alcohol, pentyl alcohol, like that. So you need to identify functional group there. Now there are also another class of organic compounds derived from hydrocarbons, where oxygen atom is stuck in between a chain, carbon-carbon chain. See that? Oxygen atom. When that happens, it's called an ether functional group. All right. Now, just like sticking in an OH, you could have replace a hydrogen with a chlorine here. And when that happens, we call it halides. It could be methyl halide, methyl group is CH3 group, ethyl group, or alkyl halide. Alkyl is a generic name for a group derived from hydrocarbon when you remove a hydrogen. Okay. Now we're getting a little more complex here as you go down the functional groups. This is not just one single, two atoms here, single atom here. This is a group of atoms. Okay, that group of atoms, like this, carbon is bonded to oxygen with a double bond. We call that a carbonyl group. This group is called a carbonyl group. And the same carbon atom is attached to a hydrogen and the alkyl group. Alkyl group being this part. You see that? When you see that, this we call it CHO. CHO is called aldehyde. Aldehyde. Did you get it? Aldehyde. All right. Now, there's another functional group similar to aldehyde, but the difference is, in place of hydrogen, here you have a OH group, right? Alcohol group. We don't call it alcohol anymore, because when the alcohol is with the carbonyl group, we call it carboxylic acid. Carboxylic acid. Okay, the group is this. COOH, we call it. All right, now the last one is when a carbonyl group, when you have the alkyl group here, and bonded by carbonyl group and oxygen group here, it looks like it is coming from here. Yeah, acid, carboxylic acid. When a carboxylic acid reacts with the alcohol, it replaces this OH with the alkyl group. It's called an ester. Ester. Now, you need to identify these different types when you see it in an organic molecule, right? Basically, you have to pay attention to the carbonyl group and the oxygen, right? Whether you have a carbonyl group with the OH, and then it's a carboxylic acid group, carbonyl group with the H, that's aldehyde group, all right? Okay, this should have been here. Okay. Now, this is going to be one of the problems that you need to do in test, identifying functional groups in a molecule, right? Now I'm moving on to hydrocarbons, right? Remember on that chart we were doing, we were saying that organic compounds could be hydrocarbons or hydrocarbon derivatives. So derivatives are going to be alcohols, alkyl halides, ethers, carboxylic acid, esters, right. There's one more group I have there. When an alkyl group is attached to like this, it's similar to ether, but in the place of oxygen you have a carbonyl group stuck in between two alkyl groups. So that one is called ketone, okay? Ketone. So that one was not there in the question, to identify that. So we have those types. What was the ones? Alcohols, ethers, aldehydes, carboxylic acid, esters, and ketones. Did I miss anything? There's another group, one we didn't put out. Amine, like ammonia, amine also the derivative. Okay. Now, if you look at the structure of the book, the chapter-wise, we start with hydrocarbons, and then we go on to unsaturated hydrocarbons. Then we go into alcohols. Then we go into aldehyde and ketones, carboxylic acid, esters. That's what we're going to follow in this class, because these are the major organic compounds that we find. Okay. Now we're going to go into more details of the hydrocarbons now. Now these are the definitions. Okay. Now the hydrocarbons, compound that contain only carbon and hydrogen, as I said, and hydrocarbon derivatives are compound that contain carbon, hydrogen, and one or more additional elements. Those are like oxygen, OH groups, halide, chloride groups, all right? And additional elements could be group of atoms as functional groups. All right. Saturated hydrocarbon is hydrocarbon with all carbon-carbon single bond. Unsaturated hydrocarbon are carbon-hydrogen compounds with one or more carbon multiple bond. You understand multiple bonds are double bond and a triple bond, right? Okay. Now, these are all alkanes, the hydrocarbon types, saturated and unsaturated. The general name for hydrocarbon is alkane. Okay. Like we call it methane, propane, ethane, propane, butane. The general name is like a generic brand, is the alkane. Now, the straight chain alkanes, where the carbons are bonded to each other in a chain, is called open chain alkanes, like that. How many carbon atoms are there? 4. Okay, you can see that. All right. Now, branch chain alkanes, okay, are we are not talking about it here. When you stick this is the main chain, and one is sticking out. It's like a road branching off, right? All right. Now, one thing you need to know is general formula of alkanes. Now, if you have carbon number 5, what would be the formula of alkane? Formula of alkane with carbon number 5. Carbons. C5. What is the? How do you get the hydrogen number? 2n plus 2. 10 plus 2 is 12, right? All right. So I mean, any hydrocarbon, saturated hydrocarbon, have this formula. What would be the octane chemical formula? Octane is 8. C8, 16 plus 2 is 18. Okay, you got it. So that's one idea. Now also you have to understand how to show, how to draw alkanes on the paper. Okay. Now, let me show you a picture. Okay, in this diagram here, that's called methane. I'm going to show how we derive the name for alkanes, ethane and propane, the first three straight chain alkanes, and the structural formula. We call it structural formula. Sometimes we call it expanded. Right. Expanded means everything, all the bonds are shown. Now, it shows all the bonds. It's more detailed. It shows a lot of detail. That's the structure. Condensed means you don't show all the bonds, but you're trying to show some of the connectivity, right? Here, this is kind of a condensed structural formula. Here, it's only a major part of the chain is shown by a bond, but you can go further. You can write down this. This is called condensed formula. Remember, now you don't write that. Condensed formula is no bonds, right? But still you have the connectivity. That means you know carbon is connected to another carbon atom. So condensed formula this is CH2, CH3. All right? Okay. I like that. There's another way to show structure. Line angle formula, well, sometimes we drop that structural part. Line angle formula is for octane. For octane is shown here. Okay. Octane is going to be this. Condensed formula is going to be this. How many carbon atoms in octane? 8. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. All right. Now there are 8 carbon atoms. Okay, if I'm putting dots there. Okay. Now what we do is this. Drawing a structural formula, if it's a chain, we draw like this. Where you start is a carbon atom. Where you have an angle is a carbon atom. Yeah. How many carbon atoms I have? 1, 2, 3, 4, 5, 6, 7, 8. There's only 8. Right? So the octane line angle formula would be that. You're not showing hydrogens now, okay? But you are supposed to know there should be 3 hydrogens here attached to this carbon. Why?
It's 3 more bonds. 3
more bonds are missing, right? They, being a hydrocarbon, there had to be. Okay, how many hydrogens are attached to here? 2. Because there are 1, 2, and 3, 4. And 2, 2, 2, 2, and the carbon atom here is called a terminal carbon atom, right? Terminal carbon atom most of the time have 3 hydrogens, and the middle carbon atom, right, would have at least 2. Okay. Now we got that idea about the hydrocarbons now. Let's answer these questions, okay? What we understood those chemical formula, and you can have condensed formula, you can have structural formula, you can have line angle formula. You understand there are 4 types, right? Okay, for this, what would be the molecular formula?
C5S12.
Right. How do you know that? C5. Being a hydrocarbon, you need to only count number of carbon atoms. Okay, there are 5 carbon atoms. it has to, you don't have to count now hydrogens. Why? If it's a hydrocarbon, right? Unsaturated hydrocarbon, this has to be 12. If you're not sure, just count, right? You're gonna have 12 because that's the how many single bond you're gonna have. Okay, condensed formula. What would be the condensed formula now? It shows the connectivity, right? And this is tricky. Here, this is like this structure here. Yeah? What we had here, like this. I mean, we are showing it like that, right? This is a two-dimensional form, right? So how you draw it, I start with this, CH3. I'm not going to do this, normally I don't do this. And this is a CH group, and I put a square parenthesis, and you put a CH3 here. For that, because it's coming out of that, all right? So that's how we write the condensed formula. CH3, CH2. I have a problem there. Don't write on that. CH3, CH2, CH, CH3, CH3. All right. Here. Now, if you extend this question, what is the line angle formula going to be? Okay, first you have to draw this 4 carbon atoms. 1, 2, 3, 4. And you put the that here. So this is going to be a line angle formula, right? This is the carbon atom with 1 hydrogen. Okay? How many of you get in this? It's very simple, right? Okay. We're going to do the same thing here. Molecular formula, how many carbon atoms are here? 6. Okay, it's going to be C6H14, all right? 2N plus 2, right? Hydrogen. Okay, what would be the condensed formula? Let's not write on there. So you have to know that this has to be a CH. Isolate this group here. That's going to be CH, and that's going to be CH3, right? And rest is going to be CH2, CH2, CH3. Now, why we are doing all this is because we are writing down stuff on our books.
Why does that one not have a line connecting to the H?
One is missing there.
This one?
No.
Next to it, next to it.
Okay. Just
Or is
an
it
error.
missing? I didn't even notice, okay? Yeah.
Why wouldn't the last CH3 group be in parentheses? Because isn't it coming out of that C class, the CH2 group before it?
Before it? Like, then we had to do that too, right?
Right.
Terminal groups are not, okay? Terminal groups are part of the chain. You understand? Like head and the tail would be part of it. Okay, now you have to, how you draw a line diagram is you draw 5-membered line, okay? 5 carbon atom line. I'm going to draw here 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm counting more here. So it's going to be that, right? Here. Now understand this. These are carbon atoms. We normally don't highlight it with the point like that, but that's the line diagram. Okay. So line diagrams are used everywhere. Okay. The question number 8, okay, is molecular formula. That's the easy one, right? What is H? 12. Okay. What is the condensed formula?
CH3, CH2.
CH3, CH2, 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 5, right? 1, 2, 3, 4, 5. What is the line angle formula? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right. Now let me talk about this IPAC name. Okay. This is about naming chemical compounds. IPAC is International Union of Pure and Applied Chemistry. Here, IPAC nomenclature. Nomenclature is naming. What we do is we have a committee formed by all the scientists in the world, representing different countries. Okay, so they agree upon how we name stuff. Because when you publish or write up something, then they need to know what we're talking about. It's kind of a language issue. So they come up with rules. So that's what we are following. Okay, that's called the IPAC names. Okay. Now the IPAC name is for simple alkanes, for normal alkanes. The compound, we open the unbranched or straight chain alkanes. Okay, methane is. Notice the general theme. N. Where does it come from? Alkane. Okay? Now, alk means alkyl group. Now, alk come from alkyl group. Okay. This called the group with CH. One carbon group is called meth. 1 carbon. 2 carbon is called eth. 3 carbon is called bute. 3 carbon is prop. Bute, pen, hex, hept. Then we have down there octane, right? Oct, none, non, de, do, de. Dodec is 12. Tetra, dec is 14 after, 4 after 10. Do is 2 after. Hexa, dec means 6 after decade. Octa, octadec is 8 after 10. Icosane is 20, like that. Anyway, at least you had to remember up to about 10.
There's no letter.
Good question. Okay, what do you call it? Do, tetra, undecane or something, 1 decane. I think, I don't know why it's not there. Let's see in other things. Okay. What do you think? Undecane.
Yeah, that's right.
Yeah, UN. Okay. All right. That's a good question. That means you guys are paying attention, all right? That's a good thing. Okay, we go in here, IPAC naming, okay? Therefore, IPAC name for this one should be pentane, right? All right. Sometimes we call it pentane and N-pentane. N means normal. Normal means unbranched. But it's not very common to call that. Now we need to do the IPAC naming for branch alkanes. Okay. Here's the details for that. Straight continuous alkane and branch divided substituted alkane. You call it substituted because there are other groups branching off from the chain. Alkyl group. Now, if you have a branch out of this, like you had here, methane, It's called a methyl group, right? Methyl is methyl. Ethyl. Eth means two carbon, right? Propyl, YL. Butyl, butyl. Pentyl, right? If you have a series of hydrocarbons, you take out a hydrogen from each one of them, it becomes an alkyl group, all right? That could be a substituent to another long thing, sticking in there. All right. The rules. Rule seems harder than doing it because you just go ahead and try to put it together, right? I want you to go there and read it after we've done it. Okay, let me do one and come back here again. What was the first step I said? Identify the longest continuous chain. Continuous chain. Okay. There are a lot of, that's like a road with different branches coming out. You can, the continuous chain would be the one having the largest number of carbon atoms, right? Okay, which one has, this one is 3. It's not going to be largest, 1, 2, 3, 4. This one is 4. It's not going to be 1, 2, 3, 4, 5, 6, 7. This is the same, okay? 7 is the largest. Can you understand what I was doing? Okay. Okay, now 7 is the largest continuous, okay? Continuous chain. Okay, we call that chain the parent chain. Parent chain. Parent. That means it's the one that is based on, all right? Okay. Now, now we have to number the chain, okay? There are a few rules when you number that 7 here. We could have done it this way. 1, 2, 3, 4, 5, 6, 7. Or 1, 2, 3, 4, 5, 6, 7. All right. Which one you will pick? The rule says, if you label 1, 2, 3, 4, 5, 6, 7, this get 5. If you go other way around, let me do different pen. 1, 2, 3, 4, 5, 6, 7. This chain get number 2. Which way we do now? Do some problems. You're going to work this out, all right? Couple more problems. That's why the owl or the book is there. Okay. All right, already finished. What I did was, I will show you why my confusion was. In this case, I created a rule for that. The rule was pick the longest chain. That would be the parent carbon atom. Then number alkyl group to give lowest number. That was what should be given the priority. But the rule is the first branch should get the lowest number, first branch. Okay. Therefore, this should be labeled like this. Okay. I made a mistake. It should have been heptane, right? Parent chain is heptane. And that methyl group's going to be 5, 5, 2, 5, 5, trimethyl. It should be heptane. Okay. Okay, what is the rule now? The first branch, lowest number should be given to the first branch, right? Okay. Because this branch alkane business, naming branch alkane, requires the names of substituent alkyl groups, right? Complex molecule could have branches. We use the simplest branch, which was methyl or ethyl. then there could be whole different types of alkyl groups. Okay. Now you have to understand this. Let me show you. Make an alkyl group now from a hydrocarbon. How do you make an alkyl group? Just take the hydrogen out. All right. That's called CH3. It's called methyl. Right. How many alkyl groups you can create with methane? Because it's all equal, symmetrical. No matter what you take out, it's going to look the same. All right. So there's only one methyl group, regardless of pulling hydrogen from 4 different places. They're all equal positions. You understand that? Methane, all hydrogens are tetrahedrally bonded, right? So therefore only one methyl group, one alkyl group with carbon, one carbon atom. Okay. So therefore CH3 is methyl. Okay, let me write down here, methyl. How do I get a meth part? Meth stand for one carbon atom, right? Remember naming meth, Ed, prob, bute, right? So ethyl going to be what now? Now let me explain this to you. There are only one ethyl group. For example, in ethane here, all these hydrogen atoms are equal. Can you tell the difference from one from the other? No. You close your eyes, then I pull up another hydrogen from here, okay? You're not going to say it's different because it looks the same and therefore it's the same, all right? Here. So therefore only one ethyl group, okay? Now when you extend this to propyl, you're going to run into something, okay, that we're going to explain now. Now in a propane, here, 3 carbon atom hydrocarbon, here. Did you see the difference between terminal hydrogens and these hydrogens and CH2 hydrogens? They're two different, like different places, right? Now let me explain this further. This carbon atom is called a primary carbon atom. Okay, primary carbon atom is carbon attached to another carbon atom. Here, there are 2 primary carbon atoms right, in here. The secondary carbon atom, secondary means 2 attached to 2 carbon atoms. Now in these molecules you have primary 2 primary carbon atoms, so therefore primary hydrogens, right? And secondary hydrogens. You see that? 2 secondary. There are 6 primary hydrogens, which are all equal, right? But there are 2 equal secondary hydrogens. Therefore, no matter what you take out from primary, you're going to get only one propyl group, right? So which one would be that? This is going to be that one. You understand that, what I wrote there? This is the one that pulled out hydrogen from a primary. That's called propyl. Okay. Sometimes we call it N-propyl, but propyl is enough. Now if you pull the hydrogen from the secondary carbonyl atom, okay, we could have called it sec-propyl, but we use a different name. We don't call it sec-propyl. We call it isopropyl. Isopropyl. It could have been isopropyl. Okay, this could have been sec. Okay, but you use iso. Normally in chemistry, when you have a CH3 group and CH3 group like this, it's called isopropyl. This part here is called isopropyl. propyl group. Okay. If you have something like carbon, 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 carbon here, here attached to another carbon, carbon, carbon here. So this is a butane. Let me make it pentane because it's the longest chain. This substituent now going to be what now? It's going to be isopropyl, right? 2 isopropyl. I'm just showing how we use that in naming branch alkanes. Okay. Now this one is called came from butane. Why it came from that alkyl group? Why that came from butane? Because there are 4 carbon atoms, right? Okay. Now let me explain again. Ask you this. How many primary carbon atoms are in here? Everybody got it? How many? What are primary carbon atoms? Tell me again.
Bonded with only 1 carbon atom.
Right. The terminal carbon atom going to be primary. There are 2 of them at the end of the butane ring, right? Okay. The middle ones are CH2, CH2, CH3, CH2, CH2, CH3. Middle ones are going to be the secondary carbon atom. Okay. The hydrogens attached to them are called secondary protons. And the terminal carbon atoms are primary carbon atoms, therefore the hydrogen attached to them are called primary. Now, same argument, if you pull a primary, you get only 1. So that is going to be this one, where CH2, 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 CH3, right? That's we call like just the butyl group, right? Now, there's a complication here. Now I had to tell you about other things. I had to explain this. This is normal butane. What is normal butane? Straight chain alkane with 4 carbon atoms. Okay, there's an isomer of butane. The isomerism is possible when you have carbon number increase. After 3 comes the butane, 4 carbon atoms. The propane don't have isomers, but the butane has complexity of the more than 3 carbon atoms, so you can stick another one in the secondary carbon atom, next carbon atom, right? Whereas in propane, you cannot take out one and you still get the straight chain propane, right? For example, here, if you don't understand, this is propane. Is there any other way to connect this? All right. Can you connect this different way? No. There's only one isomer. What is the meaning of isomer now? Isomer is something to do with the connectivity, right? How you same molecular formula, but they are bonded differently, right? The connectivity is different. These kind of isomers are called constitutional isomers. We're going to talk about that later, okay? So anyway, propane don't have it. But if you have butane, okay, you can think of a butane like this. That's the normal butane. But you can take out one this and on a terminal and attach to a middle carbon atom in here. Can you see this is different? Because now there's a branch alkane now, right? Okay, when there's a branch alkane in a butane has 2 isomers. One is normal butane, other one is isobutane. Why do we call it iso? Did you notice that? Oh, I call it this branch here. Yeah. Like in chemistry, iso means like a victory sign here, you know, like that. So, okay, this is called isobutane. Now, if you look at this molecule right here, this is coming from isobutane. Yeah, that's a in isobutane. If you look at the isobutane molecule, there are 3 primary carbon atoms, right? Carbon atom attached to only one other carbon atom. And the middle one is attached to how many carbon atoms? 3. Then it should be called what? Primary is 1, secondary is 2, tertiary, right? Tertiary carbon atom. So therefore, you can remove a hydrogen from a primary carbon atom, you get a 1 alkyl group. Because all the primary carbon atoms are, right? There's one other possibility. You can remove only remaining hydrogen atom from the, what is the middle carbon atom, tertiary carbon atom. Then you can get a tertiary butyl group, all right? Can you tell which one is that? That one, right? Okay, so this one is called, this I cannot write here. Third butyl. Okay, this one is called sec butyl. Why is called sec butyl? Because it's coming from not no, I have a problem here. This is sec butyl. Okay, butyl, sec butyl. What did we call? Isobutyl. This one is called third butyl. Yeah, it's called third butyl. Okay, let's look at the. Okay, let me pull it down. Now, in the book, they identify different alkyl groups here. Now, this is isopropyl. This one is isobutyl. Isobutyl. Oh, okay. Did I call it isobutyl? Yes. And this one is sec butyl. Sec. That one is tertiary butyl. Remember? Okay. We got them. Okay. Now you have a good idea about the hydrocarbons. Okay. Now let's talk about now why we need to know about hydrocarbon is it's natural gas. All right, natural gas is hydrocarbons. What hydrocarbon is in natural gas? What's coming out when you methane? Methane is the, see, if you open up that, it's methane, 99%, and ethane, a little bit of ethane. It's not pure mixture. How many of you have seen a gas well in the backyards? There are a lot of controversies in how they drill and take it out. Other source of alkane is petroleum, right? Now petroleum is coming from crude oil. Let me go to this one. Do you know how they refine petroleum? They have distillation columns, right? So here you have the crude oil, and you heat it up, temperature goes up, and the volatility or the eagerness to go into gas phase depend on the molecular weight. The higher the molecular weight, boiling point is lower. If you're heavy, you cannot move, right? So same thing is true for hydrocarbons, okay? Therefore, if the boiling point increase with the carbon number, right? So therefore, what we have is series of alkanes with different carbon numbers, right? What we do is, when you drill oil, we also always get the natural gas, and then we use that one for heating and all that. And then we get the crude oil out. Under pressure, it comes out, then you collect them, and sometimes we have to pump, out of this thing, going around Texas, seen those. Then we bring them and put it here in a refinery, and you heat them up, and different fractions are obtained. If you look at this, gases will come out first, and gasoline is 5 to 12 about. See, gasoline? Mainly, gasoline can contain carbon 5 to 8, mainly. There are a few other things. It's not a totally pure mixture, only 5. Yeah, some other things. Kerosene is 12 to 16. And heating oil is like diesel, that's all these parts. Lubricating oil, they're more viscous. The mineral oil is the motor oil that you put in vehicles are hydrocarbon.